Hi guys, this is EasyElimu. I'm Vincent Kanamai. I will be taking you through Form 4 Mathematics. Stay tuned. Welcome. Our today's topic is Trigonometry, and we shall start with the basics of trigonometric ratios, which we learned in Book 2. In Book 2, we learned about how we can find these trigonometric ratios using several triangles, which was a right angle triangle and also using an isosceles triangle. We can do a review of it, whereby we had a right angle triangle, whereby we had an angle theta. And we do say that given this side as 1 and the other side as 1, we can find the hypotenuse of the triangle by taking the other side, which is the opposite of the angle, squared plus the adjacent of the angle. This is the angle theta. So the adjacent of the angle that is adjacent squared, it will give you our hypotenuse squared. And for this instance, if we have this adjacent as 1, and we also have 1 as our opposite, then that does mean that our hypotenuse, it will be 1 squared plus 1 squared. We now get, 1 squared plus 1 squared, we get the answer to be 2. So that doesn't mean that our hypotenuse here is 2. In another way, we did say that we can also use these trigonometric ratios to find also these sides of the triangle, whereby we said we can use a formula, whereby in my school I was told by my teacher, we can use a formula known as SOHCAHTOA. SOHCAHTOA. Whereby if you want to find the sine of the angle given here, you will get the opposite of the angle over the hypotenuse. That is, if you want the sine of the angle, which is sine theta, you will now get the opposite of the angle over the hypotenuse of that angle. And in some case, if you want to find the adjacent or the cos of that angle, if you want to find the cosine of the angle, the cosine of this angle, you will take the side which is adjacent to that angle, which is 1, or in other words, the side is known as the adjacent. So you take the adjacent over the hypotenuse of the angle of that triangle, I mean. And if you want to find the tangent of that angle, the tangent of the angle theta, now you will take the opposite of the angle. This side is opposite the angle theta. So you take the opposite of the angle over the adjacent of that angle. So the adjacent, if you take the opposite of the angle over the adjacent of the angle, you will be finding the tangent of that angle. Now, this is what we used in Form 2 as the basics of trigonometrical ratios, whereby in other instance, we have learned how to find the sine of the angle, the opposite of the angle, the cosine of the angle, the tangent of the angle, and the sine of that angle. In other words, we can still find any angle given using this unit triangle here as the side of the opposite being 1, adjacent 1, and hypotenuse 1. At the same time, we can use another kind of triangle known as isosceles, or it can be even also be an equivalent triangle, whereby we know this is an equivalent triangle. Let's use an equivalent triangle of sides 60 degrees 60 degrees angle, 60 degrees angle. If we divide this part into half, we shall find one of the angle here, it will be 30 degrees, and the other angle will be 30 degrees, but this will maintain to be 60 degrees, and here it will be 90 degrees. And if we use a unit triangle, let this equivalent triangle be 1 unit each side, 1, 1, 1. Then if we cut this, if we bisect this angle, we will find it will cut this line. If it is triangle ABC, you will find that the line, the perpendicular bisector of the line, this line AB, will cut the angle at ACB into 2 halves. That is 30 degrees, 30 degrees. And the line AB will be cut into 2 halves, making each half have a measurement of a half. And then that means that if this side is 1, this is a half, then we can find the height of the triangle 2, whereby we said initially that if you want to find the height, which is the opposite of either this angle or this, depending on which side you choose. Let's say we choose our angle to be 60 degrees. Then it will mean that if we want to find the angle here, then we shall say that this one we can find it with respect to this, or we can just take one of the way using this formula, whereby we can say now the opposite of that angle, which can be represented by x, let that be x. Then if you add 2 adjacent of the angle, which is a half, but if we square this, we should get our hypotenuse, which is 1. We can square and still will give us 1. So our answer will be 1 is equal to, now this is x squared plus a quarter is equals to 1. On solution, you will find that x squared plus 1 plus a quarter equals to 1. So meaning x squared is equal to 1 minus a quarter. That is 1 minus a quarter. On subtraction here, you find x squared being 1 minus a quarter, it will give you 3/4. Then, if you want the value of x, because what we want is x, not x squared, then we have to do square root on both sides. And doing square root on both sides, we find our opposite or the height of that triangle being, this one can be root 3 over 2, or it can be root 3 over root 4, which will also still give you root 3 over 2. Because root 4, square root of 4 is 2. So we find that here it will be root 3 over 2. So we have found, using basics of trigonometric ratios, we can solve any given, if you have been given any kind of a triangle or any kind of tangent, cosine, or sine equations, and be told to find either a sine or the other using these 2 triangles. It is simply the same. Now we shall see how we may form another some trigonometric ratios from the same triangles. Let's take a triangle of this shape, whereby let this angle be theta, and this one be a radius of our triangle. If this triangle, for instance, is cut from a circle, then this one, let it be our radius. So that means that if we want to find the height or the distance from this point to this point, then we shall use our trigonometric ratio, and I just gave you a formula by using or applying this SOHCAHTOA, whereby if you want to find, it will depend on the side you want, and then you choose from the sector of the formula. For example, I want to find this part, and I have the angle theta, and I also have one of the side, which is the hypotenuse, as r. So if I want to find the opposite of that triangle, then I will come and check. We have here opposite and hypotenuse, opposite and adjacent. But I don't have adjacent here. I have the measurement of hypotenuse. Thus, that means I will use this formula. So that means that if I take sine theta, sine of the angle theta, it should give me the opposite of that angle, which for instance I don't have, let it be x, over the hypotenuse of that triangle, which is r. So that means that if I want to obtain the value or the measurement of x, then I will have to multiply both sides by r, and this side also multiply by r, whereby it will give me x as r sine theta. So that means that the value of x here is represented by r sine theta. Now, we can still find the adjacent of the triangle by taking the other side of the formula. The adjacent, we have the hypotenuse, and we also have, even we can use this one. Now we can use any kind of here. But let's use cos. Then, if we want the cosine of the angle theta, the cosine of this angle, it means I will take the adjacent line to the angle, which I don't have, let it be P, over the hypotenuse of the angle, which is R. So that means that if I want to find the measurement of P, I will have to multiply both sides by R and this side by R, meaning that this and this will cancel, and then I will remain with the R cos theta. So meaning the adjacent of the triangle here, the adjacent of the triangle will be r cos theta. And we also know from book 2 that if I take this side, which is opposite squared, plus adjacent squared, I should get the hypotenuse squared. So that implies that if I take r cos theta, the adjacent, plus the opposite, which is r sine theta, this all I should square, it should give me my r squared. If I square here, because it's one measurement, it should give me, if you square, this one will be r squared. This one should give you cos squared theta plus r squared sine squared theta is equal to r squared. Now from this formula, I can factor out r, whereby r squared will be r squared into cos squared theta plus sine squared theta is equal to r squared. Now we can divide both sides by r squared and this side also by r squared, and we shall find that this r squared and r squared will cancel out and you remain with 1. This also cancels out and it will give you cos squared theta plus sine squared theta is equal to 1. And this is another trigonometric ratio we have found. We can still find another trigonometric ratio using the initials of basics of trigonometrics, whereby we said if we take this side, which is the opposite squared, we add to adjacent squared, it should give you hypotenuse squared, and we have find this. Then it doesn't mean that if we want also the tangent of the angle theta, then we shall take that the opposite of the angle, the side which is opposite is r sine theta, over the adjacent, which is r cos theta. What I do means that tangent of the angle theta is equal to the opposite of the angle over the adjacent of that angle, which will now give us that the opposite is r sin theta, and our adjacent here is r cos theta. If we do that way, we shall find that our tangent of that angle, tan theta, is equal to, now here we are saying that r is common in both numerator and denominator. So meaning we can cancel r here and cancel r in the denominator to be having sin theta over cos theta, whereby r and r cancels out to get 1. So 1 by that and this, we shall get sin theta over cos theta. So this is our second trigonometric ratio from the triangle we have here. The first one we found that cos squared theta plus sin squared theta is equal to 1. And another one we have found from that triangle is that tan theta is equal to sin theta over cos theta. Now we can do some examples. Given x equals to 2 cos theta, show that given that x equals to 2 cos theta, show that 4 minus x squared under square root over x equals to tan theta. What we should do here, we can solve this one using two methods. The first method we shall use we shall just substitute the value of x squared here from what we are being given. That is 4 minus the value of x here is 2 cos theta. So that is 2 cos theta. But remember x here is squared. Then over the value of x is 2 cos theta. On doing that, we shall find out that this one, it will be 4 minus, if we square here, we shall find 4 cos squared theta from this one. And this, all of this is under square root. So this one gives us over 2 cos theta. From this part, we can see that we can still factor out, because 4 is common in both of this side, positive part and the negative part. So on factoring out, we shall find that if we factor out 4, it will be 4 into 4, you get 1 minus 4 here. Now it will be cos squared theta over 2 cos theta. But remember, we do say that if we take sin squared theta plus cos squared theta, it should give us 1. So that actually means that if we, for example, we want sin squared theta, then it will be 1 minus, if this cos squared theta crosses the equal sign, it will be 1 minus cos squared theta, for which in case here, it is equivalent to what we have in bracket. So we can replace what we have here in bracket with 1 minus cos squared theta, whereby we shall find 4, but in place of 1 minus cos squared theta, we shall place sin squared theta over 2 cos theta. And here we have, this one can be square root. The under square root value can also be found. So meaning that the square root of 4, it will be 2, and square root of sine squared theta, it is just sine theta. So it is sine theta over now 2 cos theta. Meaning that here we have 2 common in both numerator and denominator, meaning that we can eliminate it by cancelling, and we shall find sine theta over cos theta. But remember, from our first part, we say that if we take the tangent of an angle whereby we had a triangle, and we said the tangent of that angle, it will be the opposite, which gave us the tangent of that angle gave us sine theta over cos theta, which we have here. So meaning that if we have sine theta over cos theta, it's the same as the tangent of that angle. And we have proved that if x is equal to 2 cos theta, then 4 minus x squared under the square root of now over x, it should be tan theta. We have proved and we have found. That was the first method. Then another method, another simpler method is just you draw your triangle this way and let this angle be theta. You let that angle to be theta, and if you have x equals to 2 cos theta, then it means that our cos theta here, it will be, now you divide both sides by 2, so it will be x over 2. Meaning if cos theta is equals to x over 2, then our adjacent of the angle here is x, and our hypotenuse of that near triangle is 2. So meaning we can find this angle, we can find this side from that part to that by taking the hypotenuse squared, which is 2 squared, minus the adjacent squared, which is x. Now it will be x squared. It should give us our opposite, which we seek, but it will be squared. So if we need a single, then we have to find the square root of these 2. And on finding the square root of these 2, then we have 2 squared gives 4, and x squared, it remains x squared, but all of it is under square root. So this is our opposite. So meaning this side is the square root of 4 minus x squared. But remember, we did say that tangent of an angle is the opposite of that angle over the adjacent of that angle. So if we take our opposite of the angle is square root of 4 minus x squared. So we find the square root of 4 minus x squared over, now the adjacent of the angle is x, and we have found that given that x equals to 2 cos theta, then this value is equal to tan theta just by drawing, and we can prove that way. Our next subtopic will be about waves. And in waves, we see that some of the trigonometric equations are being given in terms of waves. And this may be, maybe you may be given y equals to either sine x or cos x, or a combination of the two. Our next example, we shall see this example of wave, whereby we have here one of the part rising, a wave rising up to 1 and also dropping to a instant of -1. And we can see the wave passes through 180 degrees and also passes through that same axis, x-axis, at 360, and in that series goes after 180, it passes through the x-axis. Now we can find that this wave rises up to a maximum of 1 and also drops to a maximum of -1. So we can say that the maximum rising of the wave above the x-axis and also dropping or below the x-axis is what we refer to as amplitude. In case we have been given, for example, this is our type of wave, then our amplitude here will be 1. This is the maximum rising of our wave above the x-axis and also the maximum falling or dropping below the x-axis we have found is 1. But in this case, we can see that this wave starts from here 0 degrees, starts from 0 degrees, then cuts again and comes back and cut here to complete one circle. It completes its one circle at 360 degrees. In that case, we can say that this wave completes one circle in 360 degrees. But this one cycle is what we call a full wavelength. And this full wavelength is what we call a period of the wave. It is as a point where it is an interval where the wave takes for it to repeat itself from its initial position, then it starts repeating again. You will find it will go that way, and if you take these two intervals, the interval from here to here is the same interval from here to here, meaning that the interval from here to here is 360, and that is our period. So in this case, we can say the one circle completed in 360 degrees, then this one is equal to our period. And in other words, we know from the unit circle that 360 degrees is referred to as 2 pi radians, whereby the C here represents the radians. So we can be given several kinds of waves. For example, you are being given an equation of y equals to 2 sine x, and another equation of y equals to 3 sine x, and you are being told to identify the period of the wave and also to identify the amplitude of the wave. In that case, to do that way, you will have to draw the wave first, and then from the wave you will see the maximum rising of that wave above the x-axis, and also the minimum point where it drops below the x-axis, and that point is where you will identify as your amplitude. Then the point where, or the interval from the 0 point, or from the first point where you take from any part of the wave, be it here, and you find that if it is from this point, it goes through until it starts repeating itself, then that means the point you identify that way, then the interval becomes our period. That one will be our period. Let's see some of the examples which can be linked together with this kind of waves. For example, if you are being given that y equals to 2 sine x, then we can identify, let our x here be the angle running from 0 to, our x be an angle running from 0 to 360 degrees. Can be 2 pi radian or 360 degrees. We can select any part of the angle, whereby we can start with that 0, And if we start with 0, we can identify 2 sine x, which is our y. And we shall find that if we take x to be 0, then 2 sine x will also be 0. If we take x to be 90, 2 sine x will be 1. If we take x to be 180 degrees, then our y here will be 0. If it adds to 270 degrees, we shall find this one becomes negative 1. And if we take it to be 360 degrees, we shall find that our y here will be 0. So we can draw that kind of a wave and identify the amplitude of the wave, and also we can identify the period of the wave. For instance, now on plotting, if x equals to 0, then y is 2 sine theta. So 2 sine theta there will be 0, so meaning the wave will start from 0 here. Then at 90 degrees, then our wave will be 1, somewhere here. At 180 degrees, our wave will be at 0. At 270 degrees, our wave is negative 1, somewhere down there. And then at 360 degrees, our wave comes back and it continues that way. So meaning, if we join the two by a gentle line, we shall find that our wave will repeat itself in that manner. So meaning that if you have been asked to identify the amplitude of the wave, we said our amplitude is the maximum displacement of that wave above the x-axis and also below the x-axis. So we can find that the wave moves above the x-axis in 1 unit, that is 1. So meaning that our amplitude is equal to 1, and our period here is the interval at which the wave starts to repeat itself. And we have found, if you start from this region, you will find you will move until that region, and then you start repeating yourself. So meaning that from 0 degrees to 360 degrees, that is our period. So meaning our period here is 360 degrees. We have identified our amplitude from y equals to sine theta, sine x, whereby x starts from 0 degrees to 360 degrees, and we can identify by drawing and find the amplitude as 1 and period as 360 degrees. Our next part, we shall move and look about some formations of waves. And there we have two kinds of equation, that is y equals to sine x, and we shall also deal with the y equals to 3 sine x. Given these two equations, we can identify them by drawing them on a graph, whereby we can start by letting x, for example, here be an angle. We have been given x is between an interval of 0 to 720 degrees, from 0 degrees to 720 degrees. So meaning that our x can start from the minimum angle, which we can take it to be at 0 degrees. So meaning if we take our x to be, let x be 0 degrees, then we can identify that of y equals to sine x, and also we can find y equals to 3. We can find y equals to 3 sine x. If x is 0, then we can find sine x will also be 0 at that point. And if sine x is 0, that means that 3 multiplied by 0, it will give you 0. And if x is equal to 90 degrees for this instant, then sine x will be 1. And if sine x is 1, then that means if you take 3 by 1, you will get this point will be 3. If we add and find our x as 180 degrees, we will find sine x, sine of 180 degrees, it will give you 0. And if you take 3 multiplied by 0, it will give you 0. Now 270 as the angle, sine of 270, it will give you -1. And 3 multiplied by -1, you will find -3. If you move on with 360 degrees, the same applies. Here we shall find 0, and here the case will be the same. To 450, you will find sine 450, it will give you +1, and this one will be sine 3 sine x, it will give you 3, and 540 will give you 0, and here you will have 0 too. And then 720 degrees will give you sine 720 degrees, it will give you 1. Now we shall draw that two waves. This is y equals to sine x, and the wave of y equals to 3 sine x. We shall start with that y equals to sine x, and we shall find if it's here, this one will be 1, somewhere there, and then back here. This one is 0, so this is here, 0 again, above, that is 1, 0, 1, 0, and it continues that way, maybe 1. So if we draw that wave, we shall find our first wave, which is y equals to sine x, is equivalent to that one. Another wave is y equals to 3 sine x. So we shall find if it's 0, this one will be here at 3, back to 0, then here, -3, pass through 0, up again, 3, through 0, here, and then it comes here, then back to 0, and then up there. So on drawing, we shall find it moves that way. We can just foretell here that the waves cut the x-axis at the same time. This is our x-axis. This is our wave y equals to 3 sine x. And we have found that it cuts the x-axis at the same time with that of y equals to sine x. And we can tell that this wave of y equals to 3 sine x rises up to 3 and also drops up to negative 3. And that of y equals to sine x, the inner one, it rises up to 1 and also drops up to negative 1. So meaning that the amplitude of y equals to sine x is equal to 1. And the amplitude of y equals to 3 sine x is equal to 3, because that is the maximum displacement of the wave on x-axis. Another point to note is that this wave of y equals to sine 3 sine x, we have found that it is just passing the same points with that of y equals to sine x. The only difference is that it has stretched above the y equals to sine x by a scale factor 3. When this one is 1, this is 3, meaning it has risen with a scale factor 3. So that is a stretch. We can obtain this y equals to sine 3 sine x just by taking y equals to sine x under a transformation of a stretch transformation of factor 3. A stretch transformation, this is a stretch transformation factor 3 with the x, because it is only rising above the x-axis, but it doesn't vary in the x-axis. So meaning it will have a transformation that is a stretch with x invariant and factor 3. Example B, y equals to sine x, and another transformation or an equation of y equals to sine x plus 45. And on drawing, we can also find that if x, let's put it here, here we have x, here be x plus 45, then this is sine x and sine x plus 45. Let's say this one be 0, this one will be 45, and sine of 0 will have 0. Sine of 45 will give us the 0.71, and here we shall also have 90. So this means it will be 135, and that gives us 0.71 Given this y equals to sine x, y equals to sine x plus 45 degrees, we can find the two on a graph whereby we find the values of sine x and sine x plus 45 correspondingly using that interval you have been given. Let's draw those two waves on a graph and see what we have. For example, if we draw the first graph, that is sine x, we shall find now we have found on drawing y equals to sine x is ahead of that of y equals to sine x plus 45. And we can also see that this line of y equals to sine x is leading that of the wave of y equals to sine x plus 45. So that is behind by an angle of, if we construct this kind of an angle here, or the angle between this point, the leading angle, we find the leading angle will be 45 degrees. Now we can see that the line of y equals to sine x is leading that of sine x plus 45 with an angle of 45 degrees. So we can say that y equals to sine x leads the line of y equals to sine x plus 45 degrees by 45 degrees. The angle by which sine x leads that of sine x plus 45 degrees is referred to as a phase angle. That's the angle by which the other wave leads the other one. Leading means it starts before the other follows. So in general, from the graph we have consequently seen what we wanted to observe, and in general we can say generally, given y equals to k sine bx, let's say bx, where b and k are constants and x is equal to theta, then we can say that our k here is equal to amplitude and period will be equal to taking either 2 pi radian over the part with or the coefficient of x, the angle you have x. The coefficient of that x will give you the period, or it can be given in degrees divided by that b. That is our period. And at the same time, if you have this one can be either the same as corresponding to y equals to k cos bx, the same applies. For instance, when you have been given y equals to sine x, let's say y equals to k x plus 45 or x plus theta, which can be equivalent to y equals to k cos x plus theta, we can say generally that
K here will still represent the amplitude, and period will be obtained by taking either 2 pi radian over that b, or take in terms of degrees, it will be 360 degrees over b. You will get your period. And we said a period is the interval at which any wave starts to repeat itself in cycle. Then here, our theta here will be representing the first angle, by which that angle leads the other. By which the angle leads the other wave. That is what we shall refer to as first angle. We shall be tackling trigonometric equations, and in trigonometric equations, you can solve these equations by either two means. The first means is whereby you will just substitute directly and work out as the equations are, or you can also draw graphs of the same equation you have been provided with, and then you find the point where they coincide. The point where the two graphs coincide at any point, then that is the value we are required to find. For instance, we shall start with the first part, or the first method of finding it, whereby we shall find just using the equations itself, which may be you may be told to find sine 2x equals to 2x within the interval of 0 less than that x less than or equal to 360 degrees. For best is that if you have been given a trigonometric equation and you have been told to solve, it will be definitely be identified from which range are you working in. For our instance, we have been provided with our x ranges from 0 to 360 degrees. And sometimes you may be provided in terms of radians, whereby it will be pi radians. And here, for instance, we have sine 2x equals to cos x. Then we can start our solution here by solving each equation. We can solve this way. From this point, we know that if we have a triangle, for instance,
if this angle is x, then it definitely follows that this other angle is 90 degrees. So if this one is x, this one should be the remaining 90 minus that angle we have here, x. You will find here. And we have been told sine 2x is equal to cos x. For instance, if this is angle x, then it means sine 2x, it will be this one. We can replace angle x with what we have here. So we have been told that sine 2x is equal to cos x. Cos x. And we know if sine 2x is equal to cos x, then it means if we find the sine of 2x is the same as the sine of this angle. So meaning this one will be always equal to sine 90. Because if you find sine 2x, it will give you cos x, which is the opposite of that angle, which is the other direction. So here we shall have this way. And on doing this, we can find, because this one is the same, sine is the same, then it definitely follows that 2x is equivalent to 90 minus x. On collecting like terms, then you find 2x plus x is equal to 90. If you want to find the value of x, you will find that 3x equals to 90, and therefore the value of x alone, it will be 3x, which is equivalent to 90, divide both sides by 3, and you find your x is equivalent to 30 degrees. But remember also, in form 2, we said, here we have been given this sine 2x equals to cos x. To find that equation in a range of 0 less than 0 degrees is less than or equal to x, which is less than or equal to 360 degrees. For instance, here we have found our first x is 30 degrees, and we are dealing with a sine equation. So if we come in a unit circle, this is our unit circle. If we draw this unit circle and we divide it into these 4 equal parts, we find that if here is 0 degrees, then here will be 90 degrees, here will be 180 degrees when we go in a rotation way. Here it will be 270 degrees, and here back to 0 and also 360 degrees, and the process continues in that way. It is a periodic movement. So in other case, we also say that all the angles that are in the first quadrant are all positive. Do it be sine angle, tangent angle, or cos angle, all the angles that are acute angles less than 90 degrees, all are positive. If we move to the second quadrant, we find that the tangent angle and the cos angle will be negative, but the only angle that will be positive is the angle containing a sine angle. So meaning in the second quadrant, we shall have sine angles all being positive. And if we want to find an angle in this quadrant, it will be the maximum of that quadrant, which is 180 degrees, subtract your angle which you have. And if you want to find an angle in the fourth quadrant, we find that the only angle which will be positive there is the tangent angle, the angle containing tangent. So the equation of a tangent here will be positive. And here, if you want to find an angle in the third quadrant, it means you will take the maximum of it, which is 270 degrees, you subtract your acute angle. And acute angle here will be x, which is located in the first quadrant. You will find that when that x is positive in the first quadrant, then in the fourth quadrant, if you take 270 degrees minus x and you find the tangent of that angle, it will also be positive. The remaining quadrant, which is the fourth quadrant, we find that the only angle which will be positive here is the cosine angle. And if you want to find that angle, you will take the 360 degrees, subtract the acute angle which is in the first quadrant. The angle which will be obtained by that will be positive if you take the cosine of that angle. So definitely it means if you want to find the other angles which will be positive, depending on the range or interval you are being given, it will be periodic of what you have. What do I mean by periodic? In case it is x, if you want to find another angle which will be positive in the first quadrant, then you will take x plus the period which it will have moved, that is 360 degrees. For instance, let us see here, we have x as 30 degrees, and we have been told to find x in interval of 0 degrees less than or equal to x less than or equal to 360 degrees. Here our range indicates only that if we want our angles here, it should range from 0 degrees to 360 degrees. But if we find it is exceeding that value, then that angle doesn't belong to the range we have been given. For instance, here now, we have first x is 360 degrees. This is an acute angle because it is less than 90 degrees. So meaning it lies in the first quadrant. And here, we were dealing with a sine equation. So meaning that if we want to find another angle, it will be positive in the second quadrant. So if we want that angle, it will be now 180 degrees. You subtract the x, and our x here is 30 degrees, and you will find our second angle to be 150 degrees. So meaning that our x is either 30 degrees, 150 degrees, and if you proceed, you want another angle, you will add 30 degrees, you add 360 degrees, and you will get 390 degrees. And if you want another angle again, you add it to this one, 360 degrees, and you will come up with 510. And it continues in that periodic. But what you should get in mind that what does your range represent? Our range here is between 0 degrees to 360 degrees. So we shall find here which angle lies between this range. And we shall find the two angles which is 30 degrees and 150 degrees. So meaning that our x, it will be 30 degrees and 150 degrees only. And that is the answer of sine 2x equals to cos x. And if you find the value using your calculator, you can prove, and you will find sine of 60 degrees is equal to sine of 30 degrees because both is a half. The same applies to 150 degrees. We shall do another one containing tangent, whereby we are being given tan 3x equals to 2. That is another example 2. And we see that if we want to get the angle here, what is the value of x in the range of 0 less than or equal to x less than or equal to 2 pi radian. Here is not degrees, we are dealing with the pi radians. And if we want to get that angle, first we have to get the angle, then we convert it into pi radians. And we know that 360 degrees is equal to 2 pi radian. Let's first find the angle here. What does x represent? First of all, we have tan 3x equals to 2. For our solution here, now it will be this way. We shall find tan inverse of this 2, whereby if we need 3x first, we need to work from in out. So it will be tan 3x equals to 2. Meaning that if we find we need 3x, it's like we have to find the tan inverse of 2. And we shall get 3x equals to, if you find the tan inverse of 2, you will find it to be 63.43 degrees. 63.43 degrees. So meaning that our x here, you will get x by dividing both sides by 3. And you find x is equal to, that is 21.14. Let's take just truncate to that point. 21.14 degrees. But what we need is in pi radians. It's only in pi radians. So what we shall do is this. We are dealing with the tangent equation. And we have found x equals to 21.14 degrees. But we said this way. We can either use 1 pi radian is equal to 180 degrees. Or we can also say that 2 pi radian equals to 360 degrees. So here we have an angle of 21.14 degrees. So what does it represent in radians? We shall equate the equations, that is 360 degrees is equal to 2 pi radian. What about our angle, which is 21.14 degrees? What does it represent? So you will find it will be 2 pi radian multiplied by 21.14 divided by 360 degrees. You find out that on division, this one gives 0.11. So it's 0. Okay, let's take the whole. 0.1174 radians. Actually, it's pi radians. But we can get it to find 0.12 pi radians. For instance, that way. But we said we need it in this period of 0 to 2 pi radian. So we shall take a unit circle as normal and have this. We know that is the angle, the acute angle we're having is 0.12 pi radian. So indicating that the tangent, we know this one will be this way. So meaning that the tangent is positive in the third quadrant. So if tangent is positive in the fourth quadrant, what does here represent? We know if it is here is 0, then here should be pi over 2 because it's 90 degrees. And 90 over 180 you will get a half. So meaning it will be pi over 2. Here will be pi, and here will be 3 pi over 2, and here will be 2 pi in rotation as it goes that way. So we need here. So meaning it will be 3 pi over 2, the maximum, minus the acute angle, which we have 0.12 pi radians. And you will find our answers. Our answer, we will find it as 1.38 pi radian. If we try to find another periodic of it, you will find that on addition of 2 pi on this, you will find that x is equal to 0.12 pi radian, 1.38 pi radian. And if you go periodically, because it is only positive here and here, then if you add 2 pi to this to get another angle which is equivalent to that, you will find it will be to 2.12 pi radian. And if you want to get another angle which will be positive here, which is not 1.38, you will have to add 2 pi radian. And if you add, you will find it will be 3.38 pi radian. So you find the angle is moving in that kind of manner. But in our equation here, we were being told to find in a range of 0 less than 2 pi radian, where x lies between the middle. So we shall find this is 2.12 is past 2 pi radian. So we only take these two, whereby we will say now our x is 0.12 pi radian and 1.38 pi radian. That is our only two answer required there. So in general, what I can say, if you are being given an equation to solve, it is better to see which kind of equation you are being provided with. Most of them can be like this single equation and some are mixed. If it is a mixed, then you will have to draw a triangle to help you to identify which parts you will be dealing with. For example, the one which we did, sine 2x equals to cos x. You will have to identify the angles and then use the relationship using a triangle, and then you solve. After solving, another part which will help you is a unit circle. A divided unit circle with the 4 quadrants, whereby you will identify as I have told you. This is the act as it is shown here, but you know that L represents all angle being positive in the first quadrant, sine represents all angle being positive in the second quadrant. As you go on, this is tangent of all angles are positive in the third quadrant, and cosine of all angles are positive in the fourth quadrant and first quadrant. That is how it is done. So we shall move to another method of the same solving trigonometric equation, but using graphical method. Let's see how it does work. For instance, you may be given an equation or an equation like y equals to 2 sine x. Then you are being told, so by using a graph of y equals to 2 sine x, then solve for 2 sine x minus cos x. You have this one to draw a graph of y equals to 2 sine x. Then you should solve 2 sine x minus cos x equals to 0. The first thing you should do here is to first make your one part subject. For example, let's take 2 sine x equals to, now this one should cross the sign, the equal sign, and we shall find it will become positive cos x. So if it is that way, we have to use a graphical method. We can do it the other way by which I showed, but here we shall do it by using a graphical method. And a graphical method, then we shall decide. For instance, here we have been told we should draw this one in a range of 0 less than x, which is less than or equal to 360 degrees. In that instant, then we shall draw our graph, but first we shall find the interval through which the 2 lies. And here we shall identify x, and here 2 sine x, and here cos x. On that identification, we can start with 0 as the minimum degrees, and we shall find if we have angle 0 degrees, then sine of 0, it will give you 0. So meaning that this one will give us 0, and cos will give us 1. Move to 90 with an interval of 90. Our range is up to that point, but you can continue to what point you require, but we shall stand at that point. All these are degrees. So on doing that, we shall find that sine 90 is positive 1, but here it will give us 0. When this one comes to 0, so this one will be 2, because sine 90 is positive 1, so this one is 2. Then 0 sine 180 will be 0, meaning it will be 0, and this one will be to the other direction, negative 1. When this one is negative 2, this one will be 0. When this one is 0, this one will be positive 1. So we can draw that. We can draw that waves, two waves. That is a wave of 2 sine x and a wave of cos x. And on drawing, we shall draw it in this unit. This is 0. Let this one be 1. Here 2. Here 3. That is y equals to 2 sine x. Then that of cos x, we shall start with there. We shall find this one is equals to y equals to cos x. And on that drawing, we have seen that the two diagrams, that is the two waves, are coinciding each other at a certain point. And for instance, that of y equals to cos x is cutting y equals to 2 sine x at a certain point here. At the same time, it cuts this at a certain point here, and also at a certain point here. And so on as the wave repeats itself. But at our instant here, we are interested with the range at which the line or the two waves cut each other between the range of 0 to 360 degrees as indicated in our range. For instance, here we have the first range here which is less than 90 degrees and another range which is less than 270 degrees, but the third range is above 360 degrees. So we shall not consider that because it's beyond our interval here. And in that case, it means what? We are going only to pick 2 points, and that is the first point here and the other point here. And if you use a graph on construction, if you use a graph using the same way, you will find that this point cuts the first point here where it cuts each other. You will find this angle here is approximately 27 degrees if you use a pure graph. And here you will find it is cutting it at a point equivalent to, it's not past, but it is equivalent to 205.5 degrees or 205 degrees. It depends with your drawing how clear it is and how accurate you are. On drawing on a graph, you should get that way. So this is another way of solving trigonometric equation by using a graph or a graphical method to solve it. The first one we saw, we just do equations and we substitute and we find the values, or do it directly as they are and we find the correct answers. And here we can use the second method, which is you use it but you construct a graph and then you find the place where the two lines cut each other or coincides. Then that point is where we require, because it is what our equation has given us. Sometimes you may find you are being told, find when, for example, x, now, find the value of y when, for example, x is something like, let's say, 90 degrees. When x is 90 degrees, now you will come here, you do this way. If x equals to 90 degrees, then you will come and dot that way. So if x equals to 90 degrees, then y will be equal to, it depends with what variable you are being given. If you are being given y, then you will have to find x. But if you are being given now x, like for our case here, we are being given x as 90 degrees, then we shall come here and find what is the value of y. For example, here the first y is equal to 0. Y is 0. And at the same time, y, we find y equals to 2. y equals to positive 2. And what is this? That is in case of y equals to positive 2 when the line of sine 2 sine x. So y will be equal to this line of 2 sine x. So it is 2. The amplitude will be 2. And here amplitude will be 0. This is for the case of y equals to cos x. And this is for the case of y equals to sine 2 sine x. So amplitude here is 2 and here amplitude is 0. It should be 1, but amplitude here is 0, not 1. I mean it's not 1, it's 0 because it's directly on that point. So it's 0. And that is how we can solve the two trigonometric equations. And I can say that our equations here are solving either using equation itself and a triangle, and together with the help of a unit circle, we can greatly say that we can solve them efficiently, and also using graphical method. Thank you for listening to me.